Hello again. So yesterday I got stuck. First of all, by being online or live so long time, and secondly because suddenly the keyboard froze. So now we shall do the second half of the problem 2, and I think we got to part D. So to do this, I should make an overview of the entire construction, I think. So we start out with x, y, z. From this we get the area and t, u and v, and t, and let's see, and from this we get x and y. So we have to prove that we can go backwards from x and y to x, y, z. So we know which curve it is. So we have given x, y, and n. If n is unknown, it will come from the equation here, from the curve that lies on. So by solving this equation for n, we can find n. And we may assume that n is positive. Oh, it will have two solutions, so we just choose the positive one. All right, that means we can find t, and when we know t and n, we can find z. This is possible because y is distinct from 0. Let's I should write it not as a capital Y, as a minuscule y. And when we have t and z, how do we find x and y? When we have t, we can find u and v. And together with z, this gives x and y. So that's a one-to-one correspondence. And will they actually be sides in a right triangle? That's a good question. Yes, that must be verified, really. That's really annoying algebra. So what we need to show is that Z is actually given by the, so I found an easy way to do it, I think. These equations are the ones giving the Pythagorean triangles. So we just need to show that um, that this u squared plus v squared gives this squared. We already know that. And then we need to multiply by z squared. This is unity, of course. So it equals z squared. So they are a Pythagorean triple. So they do form a right triangle. That's only with one L, isn't it? Right. So that gives us D. Very nice. Now we have to find all the points coming from, I've started on E. We have to find all the points coming from 3, 4, 5. Oh, 4, 3. I must admit, I all the time thought this would be an even number. Interesting. We'll just check that in a while. And negative sides are allowed as well, but X and Y must have the same sign. Because we have n positive. Now. That put limits on t, of course. So let's just do the 3, 4, 5 triangle first. N equals 6, and this point is 3/5, and 4/5. And t is 4 divided by 8. And this is A and B in the construction of the Pythagorean triples. Yes. Minus nt, that's minus 3. And y, that is 36 times 1 plus a quarter divided by 5 equals 9. Minus 3.9. That's the point this one comes from. And then 435 it's still 6. All right. And t is 3/9, a third. So it's minus 2. I can actually remember having this point, knowing this point, minus 3.9, from the first time I read this chapter, or this, yeah, I don't know if it was from this exercise, but I don't think I actually did this exercise. Well, and then y, 36 times 1 plus t squared, a ninth, at 10/9. So it gives 2, but we must divide. This gives 8. We see these are all positive numbers. So we always get, oh, if z is negative, we'll get a negative number, of course. So if we just change sign on z, then we'll get the negative ones. So so 3, 4, 5 plus minus maps to minus 3 point plus minus 9, 4, 3 plus minus 5 maps to minus 2 plus minus 8. And then there is minus 4 point minus 3. I'm running out of colors here. Oops. So we put a minus on here, but not on Z. Then we get a minus here. So T, they change sign, so we get an entirely new T. So it's 5 plus x is 2 minus 4 divided is minus 2. It shouldn't accidentally be minus 3 here. well, let's do this one first. Minus 2, and then n is still the same. So when we multiply it by minus 2, we get 12. And then we have to compute y, 36 times t squared, that's 4, divided by 5, 4 divided by 5. That's just a fraction. That's very surprising. We'll have to check that. We do get a positive. There is a picture I should. It's actually a figure from the book pertaining to this exercise, where we see that the normal Pythagorean triples we have here in this part of the curve, and this is where we have the negative values of x, y, z positive, and then we go down here with negative z. So it fits as far. So far, we are agreeing with that. Now, let's see. T equals minus 2, that gives 5. 36 times 5 is 100. Oh, did I say 5? Then just cancels with z. So because I showed you the picture there, I've forgotten what we got. We got 12. And then y just turned out to be 36, didn't it? 36. Yeah. And minus 4 point minus 3. That was the red one. So they become negative. And y, x plus z gives unity, so it's minus 3. And then minus 3, 3 times 6, that gives 18. And 1 plus t was minus 3. 9, that's 10. Divided by 5, that's 2. Times 36, that's 72. So we just need to verify that this point actually do lie on the curve to make absolutely sure that we've done everything correctly. when reading the chapter, the section, I made these examples, and now we just have to change x. So the first x was -3, -2, and -3. And let's just copy this, all of it. And -3. And I forget it. 12 and 18. My. So it was all correct. I'm very pleased with myself. So that was that exercise. And thank you for today.